Hello everyone, welcome to my channel. This is my first video. In this video I want to show you how to work with the Docker, and I'll try to explain everything by using simple concepts. In this video we will learn what is the Docker, what is an image, a container, a Dockerfile. We'll create a container and then we'll run a Java Spring Boot application inside the container. And also we'll look how to upload our container to the Dockerhub. Okay, let's start. Docker is a platform for running your application in a container. It's kind of light virtual machine, but virtual machines preceded the Docker. So Docker is a modern technology. It is faster, consumes less resources, takes less space on a machine, easily to configure and run, and has many other benefits over virtual machines. With Docker, you do not need to prepare a server for deploying your application. You can just run your app locally in a container and then simply deploy this container to any server, so it will work equally on any machine. For instance, in one container you can run a backend, in another a frontend, and in third a database, and so on. Docker is a universal tool, so it can be used with an application written on any programming languages. Let's move to basic concepts. What is a container? Container is an isolated virtual environment represented as a Linux-based system which you can configure by installing required programs and your application, and then run this container anywhere. What is an image? Image is a kind of template from which you can create many identical containers. An image contains all necessary information about configuration, programs, variables, set of executable commands needed to create and run your container. Note that an image consists of layers, and every next executed command presents as a separate layer. It helps Docker to store less space on a machine, because when you download an image, Docker downloads only layers missing on your machine. A Dockerfile. It's a file which contains a set of instructions to build an image. And the last, what is the Dockerhub? Dockerhub is a remote Docker container repository. There you can find an already configured containers for running your application. Also, you can upload your own container to the Dockerhub, and then it will be able for download on any machine with installed Docker. Enough with theory, let's move to practice. At first, you need to install Docker on your machine. I will not show you this process because it's quite easy and you can find it on the official Docker website. I work on Windows and I have Docker Desktop installed. It's a graphical interface for using the Docker. Here we can see the images page and the containers page. As you can see, I have no any containers and I have no any images. We will work in a command line and look what is happening with our images and containers in the Docker Desktop user interface. Let me show you how to download an image. To do this, we need to write a command docker pull and write the name of an image which we want to download. For example, it would be Mongo. You can define the version, but if you will not define the version, the Docker will download it with latest version which is able on the Dockerhub. As you can see, Docker downloads only layers which missed on our local machine. Note that the Docker put layers in a cache, so when you download another image with same layers, the Docker will download only missing layers. It saves lots of space on your machine. Let me skip downloading process. Downloading finished. So now we can work with this image. But the Mongo image is quite huge, and to show you how to work with the Docker, I want to use more light image. It would be Ubuntu. Docker pull Ubuntu. It will be downloaded quite faster. because it's already exists. As you can see, now we have a Ubuntu image on our local machine. So let's run our container from the Ubuntu image. To do it, we need to write docker run -i -t -name docker test Ubuntu. And now our container is running, and our command line now inside the container. We can check it by writing the ls command to see that here we have a standard Linux file system. Let me explain what we have done with our commands. Docker run means that we run the container from the image. -i, it's abbreviated from interactive mode. It keeps std in stream opened even when we leave the container. -t, it's abbreviation from tty. In other words, it means that you will be able to execute commands in a familiar terminal which works with std in and std out streams of container. So simply remember that to interact with the container, you need to write both of these commands. --name means that the next word would be the name of our container. It is docker test in our example. And the last word is Ubuntu. It's a name of an image from which we want to create a container. As we see in our UI interface, that we have running docker test container, which based on Ubuntu image. Okay, let me show you how to install something inside the container. For example, we want to install Java. To do this, we need to write apt update. It would be quite long, so let me skip the downloading process. Next, let's write apt install default JRE. Install default JRE. Yes, it would be quite long, so let's skip the downloading process. So, the downloading completed, and now we have the customized container. Let me exit from this container. Now you can see that the container stopped, and let's remove this container because we doesn't need it. rm means remove docker test. Okay, now container is removed. But in the Dockerhub, there are already lots of containers with all that we need for start. For instance, a container with an installed OpenJDK. Let's download this container and run it. We can do it without pull command, just with command run. Docker run -it. It's a combination of -i -t -it -name docker test OpenJDK and bash. Let me explain what does mean bash. Bash means that this command will be executed after container start. Okay, our container downloaded and started. We can see it in Docker desktop. So now we are in the bash, and we can check that here we have Java installed in the container. Let me show it. Java -version. Okay, we have a Java with 16 version installed. Also, because we run container in interactive mode, we can exit from a container with keyboard shortcut Ctrl+P, Ctrl+Q, and it will still be working. So we can see that it's running. Now we can already attach to our container docker attach docker test, and as you see, we can run some commands inside it. But if we will print the command exit, which exits the bash command, we will also stop the container. It's okay that container can be stopped in any moment. Let me show you it. It's okay, it's stopped. Because container runs only while the command with which it was launched running. You can rerun the container with the command start. Docker start docker test. And because it has started first time with the bash command, now we can print the command docker ps and see that our container were started with the command bash again. Let me remove this container. Docker stop docker test docker run docker test, and now we have no any container running. Let me show you. Here I have a simple Spring Boot application. Let me show you what does it do. java-jar docker test.jar. Jar, it's a Java archive, and we see it started on a 5000 port. We can go to the localhost 5000 and see that this application only shows us the index page with hello from Docker container phrase and time. And as you can see, here we have a current time for which is equals with our local machine time. Okay, let's stop this application. I want to run this application inside a container. Let me do this. At first, I need to run a new container on the which is based on OpenJDK. Docker run -d it -d, its abbreviation means detached. In this mode, container will run in the background. Next, new command -p. It supports. We wire our local machine port 5000 on the container port 5000, so it will be able on this port. Name docker test, open JDK, name of an image, and the command with which we want to start it. Okay, now it's working. And now if we will refresh this page, we see nothing because our application is not running, but our container is running, and we need to start our application inside the container. Firstly, we need to copy our dockertest.jar file inside a container. To do this, we need to write this command: docker cp copy docker. Now we write the file which we want to copy, but because we are already inside this folder, we just write the name of file, and next we print the name of our container, docker test, colon, then slash home slash docker test.jar. It would be the path to our file inside the container. Let's do it. Okay, everything's fine. Let's attach to the container docker attach docker test. Now we are inside our container. Let me show you what is inside of the home directory. We have here our file. Let's start it. Java jar dockerfile. Oh, sorry, dockertest.jar. Let's wait a couple of seconds, and now it started. Now, if we refresh our page, we see our application is working inside the container. We see the difference between the time inside the container and time on our local machine. It's because in a container no time zone defined. By this difference we can understand that the app is running from a container. Next, I want to show you what is the Dockerfile and how to work with it. Let us do the same thing, run our Spring Boot application inside a container with Dockerfile. Firstly, let's stop our application. Let's exit from the bash. Let's remove our container. And now we see that we have no any containers. For now, let me show you the Dockerfile. Here we have a bunch of commands. First command is from, sets the parent image from which we want to create our own image. It would be OpenGDK with 11 version. Next command is a working directory, which sets the working directory for next instructions such as copy and cmd. Next command would be copy. It's copy the file from the current directory, because the Dockerfile together with the dockertest.jar file in one folder. We just write the name of the file, and next we write the path inside a container where we want to copy our file. It would be /home/dockertest.jar. And next the cmd command, which means command. This command tells the Docker which command line commands would be executed after container starting. This command means that after container start would be running command line command java jar docker test jar. It has JSON array syntax. To build an image from our Dockerfile, we go to the console and write docker build -t docker test. -t means tag of our new image. Oh, sorry. Let's look what kind of image does we have. We have no docker test image. Docker test, and next we need to print dot. It's a path to our file, Dockerfile. We are already inside this folder. We just print the dot. Print enter, and let's wait a couple of seconds. Now let's go to the Docker desktop, and now we see that here we have new image Docker test from which we can create our container. Let's run our container from an image. Print docker run -d in detach mode -p ports outer inner --name docker test and name of an image docker test. Yeah, we see that it's running now. Let's refresh our website, and we see that our application is running. And if we will stop our container docker stop docker test, we will see that we can't connect to our application. Now let's rerun docker start docker test our container, and also refresh, and see the difference in time between the current time and time inside the container. But let me show you how to configure the time inside the container. We can do it with the time zone global environment. To set global environment, we can do it from the Dockerfile or from the console. Let me show you how to do it from the console. At first, let's stop our container. Next, let's remove this docker test. We see that we have no any container now. And now let me show you how to define the environment variable. To do this, we just print our previous command with this flag -e means environment, and prints TZ time zone equal Europe Moscow. It's my time zone. Let's run it. See that the container is running, and let's refresh our page. And as we see, time changed to our current local machine time. But what if we want to run our container on another machine? How to move it there? To do this, we can upload our container to the Dockerhub, and after that we can download from the Dockerhub our container on any machine in the world. At first, let's print the command docker commit docker test and the name with which we want to upload it. Docker commit means that we say to Docker that we want this container to be uploaded. Press enter, and now we can push it to the Dockerhub. Docker push, and next we print the name which we defined previously. Note that apoptos, it's my nickname, it only needed for uniquely define your container on the Docker Hub, because there are lots of containers. Let me skip the uploading process. Uploading finished. Now, if we refresh the Docker Hub page, we see that I have the Docker test container there. But now I also have a Docker test container running on my machine. So let me stop it. Docker stop, Docker test, and remove it. Docker rm Docker test. Also, let's remove an image. Docker rmi means remove image. Docker test. And also we have an apoptos Docker test image. Rmi apoptos Docker test. Okay, it's deleted successfully. Now we have no such image on our local machine, and if we will try to refresh our page with our application, we see that there nothing happened. Now we can run our application straight from the Docker Hub. To do this, let's print the command docker run -d -p 5000 -name docker test apoptos docker test. Press enter and see that Docker is unable to find image locally, so it downloads from Docker Hub. Let's look inside the Docker desktop and see that the Docker test container is running, and let's refresh our page and see that it's okay. Our application is running with the current time inside. We have come to the end. Thank you for watching this video. Today we have learned everything you need to know for starting to work with the Docker on your own. In next video we will learn how to work with Docker Compose. We'll run a simple Spring Boot Java application which connects to Postgres in one container and runs the Postgres database itself in another container. And also we'll see how to work with Docker volumes. Hit the like button, and if you want to see more, make sure you're subscribed to the channel. Have an awesome day. I'll see you once again in the next one.